it looks like just about everybody's here, so we'll get going. And so hopefully you guys got the sort of outline I sent earlier this weekend for kind of what we're aiming to take care of this week. Hopefully everybody's safe and sound from the fire truck. Nobody got burned, right? Okay, sweet. So we're going to try to kind of follow that outline that we shot through. So as we finished off talking about on Monday, the idea was to finish off having some subjects whose data is sort of cleaned up from some artifacts and ready to take forward into what we'll call post-processing. So we'll talk about what that means today a little bit, and we'll have those ready because we'll start with a sample subject, and then like we've been doing in the classes up until now, we'll build from one sample subject. We'll basically do one subject by hand through the GUI. We'll export the code that underlied that manual process through the GUI into an editor script, and then we'll start modifying that script to make it dynamically linked to go through our sort of for loop as we've been practicing with too. So we'll follow this process essentially. First, just watch what I do. I'll try to do it once, and you don't have to really do much other than watch and take notes and try to get a sense for what is happening processing-wise. And then we'll follow from watching, we'll kind of go to crawl, walk, run, the way that we've been going through the rest of the class so far. So we'll kind of follow that as normal. Just stop me if you guys have questions or if it doesn't make sense, and I'll try to stop along the way and try to discuss some of the conceptual issues of sort of what we're doing and why as we show you in sort of how to do these next steps. Right? So we've done a lot of EEG processing, and what we're going to do today is talking about that core point of moving from EEG, transferring the data into the ERP side that we're aiming for. Because from the ERPs is where we're actually going to derive our results, our analyses, our conclusions, figures, all that kind of good stuff. So does that sound pretty good? Okay, so I got everybody's lab reports in from last week, so that looks really good. Thank you guys. It looks like everybody's kind of on track. You're getting a good feel for sort of that reflective process, sort of looking pretty good along those lines. So thank you guys for keeping on track, keeping on top of that. I'm reading that stuff. I'm getting good feedback from you guys. So a couple of you guys said that you kind of want to be able to also include people who are left-handed in the study. So let's do that. If you have left-handers in your group, go ahead and include them as subjects. And what this does is allows us to actually explore the difference of that lateralization from the handedness in the experiment. So you can go ahead and do that as we move into the data collection session some more. That'll give you some more new subjects to test, and it'll give you some other hypotheses to explore in your data as well. So you can explore that, essentially use that as a covariate in the analysis, the handedness factor. So we can do that, and from here moving forward, we'll give you more time in the labs too. So as we've been talking about through the course, I'm going to be backing off more and more and more and giving you guys more and more independence and autonomy. Once we kind of wrap up these steps of learning what to do, then I'm going to kind of ship off to you guys and have you guys do it. I'll work with you guys individually on any of the modifications you need along those lines, and we'll kind of go from there. Does that sound pretty good? Do you guys have any questions before we get started? Okay, cool. Everything worked reasonably well last time. Everybody has a couple subjects worth of data to be able to get working with. Okay, so what we'll do is I will show a sample version of working through some data for one subject. The first time through, why don't you guys just watch and take notes, ask questions, and then we'll do it again. And you guys can work with me together. And then we'll build into the scripts and stuff like that. Does that sound pretty good? Okay, cool. And then next week, we'll be in like full data collection, full data analysis modes, and we'll stick with our rotations, groups 1, group 2, group 3, group 4, and you can use that time in the lab to both collect the data as well as document some of the training processes that you guys can involve in some of your projects. Sound pretty good? Okay, so I'll try to take a screencast of this as we move through it, and let's see. So do that, and start moving through here. And And then I'll try to upload this once we're done as a resource for you guys to follow along in case we need it. So the idea here is that we want to move from what we started off with as EEG data. Remember, we had EEG data kind of moving like this, and you had different events that happened at different points in time, right? So you had stimuli here that would come up on the screen, and another stimuli, right? And maybe that lasted for a period of time. We call these little epochs, right? Or windows. You guys remember that? Okay. And you had another one that might last through here. Now, you guys remember what the time frame was on these windows that we kind of sliced and diced in our epoching step of the data processing? Exactly. So we went about negative 200 milliseconds. We went all the way out to about 1500 milliseconds. So this gave us our window, our epoch, right? And what do we use this negative 200 millisecond time period for? Sorry?
It's a pre-stimulus?
It's definitely a pre-stimulus period, absolutely. We can kind of use it as a baseline control as well, right? So when we look at this pattern of data, it's going to be kind of relative to what was happening before a stimulus popped up on the screen and might elicit some pattern of activity, right? Now, I drew this pattern a little bit different than this EEG here. What is this supposed to represent? Yeah, kind of the response. So that's going to be our event-related potential. Remember, now we get this by averaging this together with this, right? So this is what we're going to talk about today, is how do we get these ERPs that are going to look more like that than these noisy EEG patterns. Right? So you guys have been doing a lot of artifact rejection, working through all those 32 EEG channels, right? Looks really messy, right? Okay, so we're going to move from this messy EEG to a little bit cleaner ERP signal, and this is where that averaging process comes in, where we account for some of that noise. And the idea here is we're averaging out the noise so that the signal is hopefully what remains. And we can then compare that to a different condition, right? So let's say if this is a memory task, these might be old trials that you remember, and you might compare that to a different ERP for new trials or things that you might have forgotten. Right? So that's kind of what we're going to work on today. We're going to moving from this EEG section. So you've already epoched the data into these. We're now going to average into event-related potentials and begin to compare condition A to condition B. And you can even subtract those to not just get our ERP plots, but when you subtract that within, say, a given latency or time window, right? That can give us our topographic map looking down on the head of your nose, your left ear, and your right ear. And you might find that there's a big pattern of activity that's of the difference between these two conditions from these two latency points in time. And maybe it might be left parietal or mid-frontal or something like that that we've talked about. Good sort of overview vision. You guys ready to get into the nitty-gritty? How we make all the magic happen here? All right, let's see if this works. And so, let's take a walk through this data. So what we're going to do is I've got MATLAB set up, and we've got our path directory set here. We've also set our broader path for EEGlab already. And remember, we set our sort of shortcut key up here, so we don't even have to type in EEGlab anymore, do we? We just hit this button. We start by bringing up our GUI, right? GUI, Graphic User Interface. Now what we're going to do is just like normal, we are going to hit File. We're going to load an existing data set, and what it's going to bring up for me, I'm going to navigate to my cleaned up data. So similar to yours, right? I have some data that I cleaned up just like you guys did. And remember, we followed this really informative naming structure. So in this case, let's say I start with subject 3. It's been resampled, right? So it's downsampled to 256 hertz. We created an events list. It was epicked. It was then cleaned with ICA. There were components that were rejected, and then I did artifact rejection. So CR and AR, that's the nomenclature that I use. And that way it helps remind us, what do we do to this data so that we have a good sort of foundation to know that we're working with the right data as we take the next steps forward. So importantly, we've rejected our artifacts. So now we can take this EEG data, and we're going to create an averaged ERP to begin working with. So all we do is we grab that, we load that in, and we don't need to really do anything else to it in our EEG lab tools. Instead, we're going to come to our ERPlab menu, and because what we want to do is create an averaged ERP, Javier Lopez Calderon and Steve Luck have programmed a very nice instruction for us. All we have to do is click Compute Averaged ERPs. And it's going to ask us for a little bit of basic information. So all you have to do is basically hit Run. We have all the preset settings is exactly as they should be, so really nice and easy for you. It's going to include the standard of the error of the mean. You run that sucker, it's going to ask if you want to continue. Just say yes. And here's, just like before in our EEG lab system, it's going to ask us, so now it's no longer an EEG data set, it's an ERP data set. So you'll see this in the structure. It'll be .ERP, not .EEG. So we'll call this an ERP set, and we're just going to name it. So this was subject 3, and I'll just start nice and simple and name it that. Okay? And we don't need to save it yet. Let's just hit OK. When we do that, the next steps we're going to do is we're going to apply our channel, or excuse me, our bin operations. So who remembers what a bin is? Yes, Stormy?
Categories?
Yeah, it's a category. Okay, a category of what?
Like different characteristics around
Characteristics of what?
characteristics of like the data.
Yeah, so we talked about kind of like sorting our socks, right? So we have all of our different event codes, and you want to put them into categories. So you put the colors and the whites in different bins. But then you have more specific bins of just colored stripes. And you can, right, layer these different kinds of categories. And that's what's going to give us those ERP conditions that we plot against each other. Times when we remember versus times when we forget. And so we're going to create this bin operations file, which is going to take our bins that you've already created in your events list in the last classes, and it's going to apply operations to them. So you're going to average bins together, or you're going to add bins or subtract them to create our difference waves. Okay? Now this is auto-populated here, but in case it's not, the way you're going to do this is you're going to go to Load List. So I'll just do that for you here. Load our list. And you can navigate to our class folder where we essentially have, in fact, in this case, it's my downloads, but in our events list, I did our bin operations file, the updated. So all we're going to do is just grab that file that I've already written for you, and you can check this little box at the bottom that says send the file rather than the individual equations. And this is going to be really helpful when we later program the script, the code underlying it. That means it's not going to put a big code of all this into your script, but just one link to the file. Okie doke. And all you're going to do otherwise is just hit run. So nice and easy. You run that sucker, and you'll see MATLAB thinking in the background. It's applying all those bins, hundreds of them that we created, so that now you can explore all the different types of hypotheses you might have in the data to compare all sorts of different conditions for implicit memory, explicit memory, pre-stimulus, all sorts of good things. And I had a question, Stormy.
Yeah, so what work that you did before you did bin operations?
Before we did bin operations, we just created an averaged ERP. And it's still thinking it'll probably go to about 400 bins, and it'll just keep going and going and going. And that'll be kind of what we do. Okay? So we'll let that think its way through. And in the meantime, you hang out. kind of the nice part about programming. You get a little bit of a break. So and there it is. So let's take a look at what MATLAB's command window is telling us. Okay, and it shows us, here's our equivalent command. We did bin operator, and you applied this file. Okay, so since you asked, Stormy, first what we did, let's type our EEG history, so H, and we see we get our basic command, how we loaded the file in. So let's start building that script. Okay, so we paste that in, just like you guys are used to. All right, and we open this up. We see that all we did was we opened our EEGlab and we loaded our data set. The file name was this file, and the path of where that file lived was this directory, which you guys are all pretty familiar with by now. Okay, so now since we didn't work in EEGlab anymore, we want to get our script commands out. Now we do, instead of EEGH, we're working with ERPs now, right? So let's just switch to ERPH. And check this out. Now we get these extra commands here. And I'll show you what we did. So we copy those and let's paste them back into our little script. Okay, so what we did was, first we did our average ERPs, okay? And then we did our bin operations. And for that we applied this text file. Super easy, right? Any questions? Okay. So, we'll come back, as you might imagine from last class, we'll come back into dynamically changing these a little bit later. But let's just set our structural foundation in place first. Okie doke. So, now that we're there, let's use our GUI and see what else we can do with ERPs. Okay? Now, let's take a little bit of a look here. Let's save that ERP now. Okay? So we come down, let's see if I can move this over. So go to ERPlab, and all we want to do is save our ERP set. Okay, now you don't even have to save it as. Let's just, actually let's save as to make sure that we put the right name in there. And that's all we kind of have to do. Now notice, all I do is I just call it our system. Nice and easy, no other name yet, just call it number 3. And you can imagine, what are we going to do with that number later on when we dynamically link it through? Was there a little nifty code that we used? What was it? Subj. And what did subj equal on our code? Number to string. So all we're going to do is just have this there. And it'll, just like you remember, it'll loop it all the way through. So we'll make it nice and easy. Alright, so let's just save it like that. Okay, and let's make sure we add that to our script. So let's type ERPH again, and we get that last command we put in, copy it, and let's put it in our editor. Okay, so I'll show you what we got here. So all we did is the code for that was save my ERP, and the ERP name we gave it was number 3, and it saves it as 3.erp. And the path that it saves it in is this directory. Does that feel kind of comfortable for you guys? Any big surprises? Makes a lot of sense based on what you're doing the last couple of classes, right? All right, and you can imagine where we might be going next, right? Yeah? All right. So, let's see here. Now what you want to do at this point, right, is let's plot those ERPs. So you go to plot ERP waveforms. Okay. Now, what we're going to look at, this looks kind of crazy gobbledygook at first, right? But this is actually exactly what you guys worked on the very first day of class. Do you remember when we were working through this? So take a little cruise through what this is asking us. What was the analogy we used for MATLAB and EEG lab on that first day? What's it like for us? It's our servant, right? So you're the king of the castle, the queen of the household, right? And you say, servant. What does it say? It says, oh yes, yes, master, what can I do for you, right? Okay, and what does it want to do for you? What did Forrest Gump want to do? Well, he wanted to run, okay. What else did we say in the analogy back then? When he was in boot camp?
Do exactly what you say.
Exactly what you say. So all it wants to do is exactly what you tell it to. So you just said, servant, give me some ERPs plotted, right? And it says, great. I want to do exactly what you tell me to, but I need some information, right? They want to know, what bins do you want to plot? Do you want to plot all of them? There's like 376 here. That's going to be a pretty crazy plot. So let's uncheck this box. And instead, you can click this little button for browse. And let's pick the specific bins that we might want to plot. So in this case, we might want to plot very simply our hits and our correct rejections. You guys remember what hits and correct rejections are? What was it, Jordan?
Implicit memory?
Explicit memory, yeah. Okay, so what are hit? What's a hit? Huh? Well, let's start with what you guys might remember more easily. What's a false alarm? We just had one. Yeah.
When you say something is old, it's actually new.
Exactly. So when you say, oh yeah, this is definitely something I remember, and you're totally wrong, right? You have a false memory, false alarm. Somebody pulls the fire, yeah, pull the fire alarm, there's definitely something here, and everybody runs out, and you're like, oh wait, false alarm. So if we start with that framework, what's a hit? Yeah.
When it's old, and you actually say it's old.
Yes. Okay. And a correct rejection is what?
When it's new, you say it's new.
Exactly. So we're comparing two things that are correct. And the only thing that differs is if you remember it from the past. So that's why it's going to be a good measurement for explicit memory joy. So let's grab what it ends up being bin 82 there, because it's our old conditions that are highly confident and sort of confident, or hits. And it ends up being, we can grab that, you can hold down the control key and scroll down a little bit more, I think it's 139. That's our correct rejection. So it's our new items that were confident and not so confident, but still correct rejections. And if you just do that, just using the GUI here, hit OK, and look what it did. It populated 82 and 139. So remember, our servant is asking us, what do you want us to plot? Because I want to plot exactly what you asked for, right? So we don't want all bins, we just want these two. Do we want to plot all of our channels? Let's just plot 1 through 32, because those are the main brain channels, right? Okay, so we don't have to, we can uncheck this and we'll just switch 38 to 32. Boom. And that's pretty much it for everything else you need. Let's hit plot. And we can see that after all this work you've done all semester, we finally, this is where all the magic happens. Right? This is all the good stuff. This is what you need to write your thesis. You got to know, what did we find? Okay, so we can see all the 32 channels. And who remembers what we did when we sort of explored this data the first week of class? How do you take a closer look at here? Well, we just plotted. What would you do now? Do you remember? Really easy. You just click on one of these. So let's click on FC2, for example. And it'll zoom in. And we can see that it gives us a lot of the information that we need. This is fun. Okay, so we see our pre-stimulus baseline, right? And it goes all the way out here to our window. Yeah? Cool, cool. And we can see that just like we might have hypothesized, let's say between a certain time point, this window, we call these latencies, right? Okay, so let's say maybe this looks like it's about 700, this is 800, so this might be, I don't know, let's say 900 milliseconds. Right? So you have all this difference between conditions. So something's happening in the brain differently between the times when you have a hit versus times when you have a correct rejection. And it's happening differently at different times. Okay? Now, you guys remember what we talked about a little bit from Steve Luck's book that we were doing some readings in. We said there's a real danger in over-interpreting a single subject's data, right? It's highly variable. That's why we need lots of sample size, lots of subjects, and get a nice stable signal. Because these signals tend to change, right? So these are very variable. But this is a good place to start. And the reason that we want to plot these individual subjects is very simple. Okay, we're not going to over-interpret this data. All we're going to do here is we're going to use it for a sanity check. So what we want to do is look for other types of artifacts. So you guys just cleaned up a lot of these trial-wise artifacts, blinks and all that kind of stuff. Here we want to make sure that it's kind of indicative of pretty reasonable processing. So what I mean by that is that we have our baseline conditions here are pretty much stable, and then the changes happen after our stimulus onset. Okay? So if you have artifacts in your data that maybe you missed or slipped through, what you'll see is this pre-stimulus period, it might come down like this, or it might start up like this. Now that's not really indicative of something that we want, right? Because it's not really a baseline then. It's going to overcorrect our post-stimulus activity. You know what I'm saying? Okay, so that's what we're going to plot this for. Just a sanity check, inspect, big picture view. Is there anything that jumps out to us that this might be a subject we have to exclude from our analysis? And it lets you know if maybe you did that artifact correction process earlier properly. Make sense? So don't get too excited about a little difference between stuff just yet. We'll get to that. Does that sound pretty good? Okay. So, let's take a look here. So we can cross that out. Now let's come back to take a look at our programming. Okay? Because what we now want to do is that next step, right? What's the data we do want to over-interpret a little bit? It's our group data, our average of all our subjects together. Yeah? So in order to do that, we need to do this for everybody else. And as you might imagine, this is where we're going to use that for loop magic that we've been working with in the coding. Okay? So, in order to create a grand average, we need to first process everybody. Now you can do everything we just did by hand, clicking in the GUI, but ain't nobody have time for that, right? Okay. Let's do it fast, let's be efficient. So what I'll do is let's rebuild this a little bit like we did in our earlier EEG script. You guys ready for that? Okay. So I'll rebuild this, and then I'll upload it to Blackboard, and then you guys can download it, and you guys can modify it as you need to for your particular directory in the file. Does that sound like a pretty good plan? Now before we dive into this, are there questions? Comments, anything before we jump in? Are you guys ready to roll? Alright. So I'm going to just bring this down a little bit so you can see it. Okay, so what did we start with last time? What did we kind of start with up here at the top? Oh, exactly. The number? What? The word. Alright, alright. Because it's a for loop. Now what if we open this loop up with the command of for, what do we have to close it with at the bottom? N. Exactly. So we come all the way down here and we close it with N. Okay. Now, for, let's say S equals, now we had it for subject number 3, right? Boom. And when we define what that loop goes through, we had S equals 3. Notice our for loop comes down and closes. And this is really nifty. It tells us what's in the loop. You guys remember this? All right. What are we going to do next? There's a little pop quiz for you. Huh?
Copy and paste the codes and put the names in
Right. Okay. So if anybody didn't hear her say it, she said copy and paste the codes and put some names to them. So what codes exactly?
there. The purple ones.
All right, the purple ones. There's lots of purple here. Help me out. Pretend I don't know anything.
So start on the 3 resample list.
Oh, okay. 3 resample. So this big purple code, right? And what is this?
That's your
It's just the name of the file, right? So what we want to do is we're going to start. We'll place some spacings in here, right? And we're going to define what our file name is. We're going to define our file path. And then we'll define what our bin operations is. And then we'll define our, what we're going to save it as down here, our purple, right? So, bear with me, we'll add that in. Now what does that do? What does it accomplish when we do that, Lucia?
it cleans up your code.
Cleans up your code how? You're right.
Organizes it.
Huh?
It organizes it.
Yeah, it organizes it so that you can change it with other people, right? So that you don't have to go through and change this 100 times. You just change it once up here. So, what's one more thing that you said not just a moment ago that we need to add to our code? What do we need to follow up with our S equals 3? Subj. What did subj equal then? Anybody remember? Num2 string. Now who remembers what that accomplishes? What is this telling the computer to do? When we define a new variable, subj for subject, and we say it's equal to this little nifty transformation, number2 string, it's turning our definition of S here, which is our number 3, into a string, which means a letter that can be saved as a file name down here, or called as a file name here. So MATLAB's one big, really, really smart, but really, really dumb calculator. Right? And it's going to do, like Forrest Gump in boot camp, it's just going to do whatever you tell it to. And if you don't tell it that the number is actually a letter, it's going to look for this number to calculate as a calculator, instead of as a letter to read. Okay, so we got that done. Good job. Now we just do exactly what Perseids told us to do, which is first we want to define some variables. Let's say our file in name is going to be equal to something. We're going to say our file in path is going to be equal to something else. We're going to say our bin operation name is going to be defined as something. And we're going to say our ERP file name is going to be defined as something else. All right, so Perseids, help me out again. I just forgot everything you told me to do. Where do I got to put this piece of information?
So you copy and paste on your file name?
Under file in, right? The file that we load in the name.
Yes.
Okay, let's paste that sucker in. Now, what do I do now? Once I did that, do I have to replace anything else?
Now you replace your code with the name.
Yeah, all right. So, put that there. Now we have to do something else to make this link with our name, our number. So we delete our number 3, and we use that concatenate function of the brackets. You guys remember this? We add subj, because we just defined that, and then we close our bracket. All right, let's jump down to our ERP file name that we saved down here, right? So for that, we're just going to call that essentially our, well, it turns out we don't need to redefine that, do we? We can make that down here. So right now, we need to replace this with subj. So it's really simple, because we didn't add anything else. So we turn that into that. we add that here, open bracket, SUBJ, close bracket. Now it's going to loop through in our for loop, right? Alrighty. And now we just do these path directives. So we change our path to exactly what we had. That's the path for file in. Close that. Okay, and we replace that like Perseda told us to now, here. And then we do it one more time, or, well, let's do our bin operations file. Copy there. Now, what am I missing here? Here's a pop quiz for you. We have one more thing in here, right? Where are we going to save our output file, this thing, this sucker? So let's call this our path to save out. Call ERP saving path equals that. And now we just replace that. And so when I send this up to Blackboard for you, we will save that as our ERP post processing. And we'll leave our date, May 16th, 2018. Save it, done. Okay, so how many of you guys think it'll work? Maybe?
No.
We usually get about a 50% shot on this sucker, right?
I don't think so.
You don't think so? All right, that's fine. That's fine. That's fine. You know, every time you submit a paper, there's always a reviewer out there drinking the haterade. That's Alex today. That's fine. That's fine. You guys think it'll work? So you guys are reviewers 1 and 2. Alex is the proverbial reviewer 3. Tanking your paper. Okay. All right, so let's take a look here. Now, if we see all of the subjects that we need to fill out, it goes from subject 3. Let's try it through subject 3. So let's say 4, 5, 6, 7, 8, 9, 10. Okay. 4, 5, 6, 7, 8, 9, 10. Let's try this for loop out. Now we can show this all on our screen here. Let's see how this works. So what do we do to run this, by the way? Highlight it all.
And evaluate the selection.
Evaluate selection, or our shortcut key is F9. Now, if I upload this script for you guys, by the way, in Blackboard, would you like me to add the comments in here to describe what's happening in each step? Who remembers how we commented in this? Percent sign, right? Okay, what does that do? What's that, Summer?
It makes it green, and then it just leaves the comment so that MATLAB can't see it.
Exactly, it's our invisible lemon ink writing secret against MATLAB, right? So let's do that for you right now, okay? Let's say comment, so it turns it green, we say open EGLab, and down in here, we comment and we say load in your EG file. Here, we say average your ERP file. Here we said apply bin operations. And here we have save your ERP file. So we can even clean it up by hitting right click and smart intent, which cleans it up. So for anybody who needs to remember, we opened EGLab with EG, lab command, we loaded in our file, load set. We average that by calling these commands. We applied the bin operations by calling this name, which is defined as this, which looks for that. So you guys are all you have to do is download the script and change your name, change your directory where the file lives for bin operations, and change that. So 4 easy copy pastes, you're hooked up. Yeah? Let's see if this works or if Alex is right.
I think it's going to work now.
No.
If you indented.
Now you think, oh, because we're indented.
Yeah.
Okay. Now, I think it might not work for a couple things.
Might not.
I don't know. We'll see. I've got a couple ideas of why I think we might get some error messages, but We'll see. You guys ready to run this sucker? All right. And what we want to do is look over here to see if it runs, right? So, let's say Control A. Well, let's save that sucker. Right click and evaluate section. So, we'll see if it runs. So far, so good. What we really want to see is not if it runs for one subject, but if it continues to loop through multiple ones. Because that's the magic of our for loop, yeah? Okie doke. So this is why a lot of computer programmers like to drink a lot of Mountain Dew, because you have plenty of time to do it. Now you just sit back, grab yourself a soda, see if it happens. Now in the meantime, I'll open up another window and I'll upload this file to Blackboard for you guys. Does that sound good? You guys keep an eye and let me know if it goofs up and gives an error message. So after Monday's work, do you guys feel comfortable adapting these scripts? You guys got a lot of rust out on Monday?
Yeah.
Okay. Let's grab Blackboard. Yeah, it was worth it though, wasn't it? Yeah. Okay, build content. We're going to create our item. I'm going to name this our ERP post-processing script. And grab
These are alpha.
All right, there it is. It's coming up, and if you scroll all the way down in our content folder for Blackboard, there's your script. Now it's on you guys to adapt to this and adjust it so that it properly fits. Now, looks like it's working over here, huh? All right, now what's one way we would see what subjects it's on? Go into our files, yeah, see what's being updated. So let's take a look there. So we're over here, and we can go by date modified. And check it out. So look, so I did this by hand, right? I did subject 3. It's already done subject 4. It's working on subject 5. And the whole time, all we're doing is drinking Mountain Dew. Guess who's wrong? Alex, I'm sorry, man.
I said it was
Oh, all right. You changed your story. Okay.
because you fixed it.
You what? I'm wrong?
You doubted yourself.
That's right.
That's
Never
true.
doubt yourself.
That's not fun.
You're right. All right. Yeah. Can't doubt yourself. You gotta trust your work. All right. So I'll give you. Since you mentioned it, I'll tell you why I thought maybe it might make some matter. So while this is thinking, right, it gives us time to think about our other stuff, like our script. So let's take a look. This is our script over here. The reason I thought it wouldn't work was a couple different things. Sometimes the bin operations likes to have it, for some reason, likes to have this whole command down here. I don't know why. It just does. Sometimes